So, good afternoon, everybody. It's a pleasure to be here today. I think it's my first physical presentation in 2 years, so that's a big milestone. I'm very excited. I hope you'll enjoy it. Indeed, the 5G Blueprint project, I'll try to talk you through it today. Um, the concept itself, as was just said, you can summarize it quite easily. It's teleoperation as depicted here, so still with the steering wheel in your hand, like you see in the demos over there also. But doing that on your full journey from start to finish. So not only on local areas, but the idea of the project is, could we realize this over in the transport sector over longer distances, really start to finish teleoperation, having the human in control, but from a remote place. This, of course, I think this was mentioned today several times. This requires a solid network connection. If you are really driving a vehicle on the public roads, 50 kilometers from you, the screen can never go black. You can never lose control, and you need to have very reliable connectivity. With 4G, you couldn't give those guarantees. 5G is an interesting candidate for the first time being able to provide you that required connectivity. So 5G is really at the core of the technical solution of the 5G Blueprint project. But you can wonder, why do you want to do this? Because yeah, if you think of automated driving, why would you drive start to finish on these with still a human in control? Well, it could be an enabler to evolve towards automated driving. Because if you drive from start to finish with a human, but physically not tied anymore to the vehicle, then over time, as your automation capabilities become better, you can take parts of your full trajectory and do those automated. Because that remote driver is not physically tied to the vehicle anymore. You can swap that person in and out from vehicle to vehicle as you see fit. So that was the idea when we concepted this project a few years ago. That could be an interesting alternative to the typical approach where you say, when you do automated driving, you have to remove the driver to have a good business case. You leave a robot on the road, and that's a really hard thing to do. It's a kind of Big Bang release. With this, we could do it more in an evolutionary manner. But of course, in the beginning, you won't have that much automation yet. In the beginning, it will be more end-to-end manual driving by that operator. This still has benefits. For instance, even if you would have no automation at all, you can still swap in and out these drivers when the vehicle is waiting. Waiting times, they are a big cost. They are when the vehicle is loaded, unloaded, waiting at the docks for the ship to arrive. You can reduce these idle times. So that's already for the business case an interesting optimization possibility for the logistics sector. Another element is that there is a shortage of truck drivers. So if you could do this on the long haul, that could be interesting because people don't have to be away from home the entire weekend. That's just a very practical thing, but people don't like doing that anymore. This really is an urgent need to find more truck drivers. There was a survey just before we defined the project. At that time, before Corona, 40% of all transport companies were hindered in their growth by just not finding people to drive their trucks. So with this new paradigm, you could add more people to the sector, not replace the current drivers, but add more people who are maybe interested by this new 9 to 5 like character of the job, and you could try to solve that problem. So there are different reasons why you want to do this and why we decided with a big consortium to investigate this. That's the economic side. You can imagine, of course, if you really look at this, not only from the technical side, but really thinking of we want to deploy this to the real world, well, then there are a lot of practical elements also to include governance, agreements, who is responsible for what, which SLAs to provide to each other, how to act upon certification of products, and so on. A lot of open questions, but our target is to have answers for them by the end of our project, so that indeed we really have a blueprint on how you could bring this to actual deployment beyond just technology exploration. So yeah, to summarize, if you look at the goals of the project, technology validation is an important part. It's bringing this to public roads, to higher driving speeds, to environments where there's maybe more shadowing effect of the network and so on. The technology part is still very important. It's not that this is already all done before us, but we, of course, are very well inspired by results like 5G mobiles here today. We continue on technology, but also on the business modeling, and so on, and on the regulatory questions just presented. So that's in a nutshell our goal. And then when I go a bit more in detail in the objectives, so when you look at the technology, just I already said the 5G part is important. It's something we continue to explore which specific tools from the total 5G toolbox are relevant to us because we don't need it all, but we need several pieces, slicing, ultra reliable low latency support, and so on. Next to the network, there are two other big pieces of technology that we are working on. The first one is just the what we call the use cases. That's the act of making things teleoperatable, or even already a first little automation added to it, so that we can go to that evolution to automated driving combined with teleoperation. That's what we call the use cases, and we do want to explore those. We are developing those. Next to that, we have what we call the enabling functions. Those are more information streams that you typically present on the screens of the operator. Because if you are just sitting behind three screens, our assumption is that you will observe less of the world than if you would be physically in that vehicle. So whatever we can do to help the driver with additional information about his or her surroundings, contextual awareness, that helps. So it's a bit an evolution of what's known as the CITS domain, bringing that to the domain of the teleoperator, putting on the screen, because it's a giant head-up display on three screens, what to be aware of as you are driving in the real public domain. So that's the enabling functions. We have several of them focusing on safety. And then we have a few that we try to, how to say, further emphasize the business potential of this paradigm of teleoperation in the logistics world. So we try to see if you can really swap in and out drivers so easily in a vehicle. Could you add logistic domain optimizations to further strengthen that business case? So that's a bit the last part of enabling functions we're working on. So I think that's on the technology. On the business side, yeah, come back to that in more detail later, but it's about exploring the business model, the commercial possibilities, and so on. And the regulatory, just yeah, legislation that needs to be changed, recommended actions for that, and so on, are also in scope. The project in itself won't change the legislation, but the blueprints should identify what needs to be done. So now diving a little bit deeper into the use cases. The first two, these are really about the teleoperation part. The use case 4.4, use case 4, it's our last one. That's just about making a truck, because we are working for logistics, so not only cars, but also trucks. Making a truck teleoperatable. And we do the same, also very interesting, on the waterways with inland barges, because there you have the same issues as with truck drivers, that you don't find inland captains, and that there's a need to be more efficient and to solve that problem. So everything I explained at the beginning, I always have the tendency to explain from a truck perception, but it's just as valid from the inland waterways. So we have a partner working on teleoperating inland barges. So those are the two teleoperation use cases. And then the next set is adding already first automation capabilities to on top of the teleoperation. So use case 2, automated in the loop docking, is basically when you end up as a truck driver at your destination, a last part of that journey is doing the maneuver to dock it so that it can be loaded, unloaded. I'm not a truck driver myself, but I've been told that this is not a trivial thing to do. They have really small margin, I think 10 centimeters on the left and the right. So this takes some time. They have to wait for another one, and so on. What we are prototyping is a solution that takes over the vehicle through the teleoperation interface, so just as the human, but it's an automated function. It uses the exact location, more accurate than normal GPS, and some logic to control the vehicle, and then it can calculate the path and do the docking for you automated through that teleoperation interface. So that's already a first optimization, a first part of your trajectory that you could automate. We're also looking at teleoperating cranes. still exploring where the business case is the best fit. We were first talking about the cranes you are seeing there depicted, these huge, how do you call Cotwald cranes, I think. But we came back from that because, yeah, they are so massive, they are such a specific type of infrastructure that we are now more looking at smaller cranes like these skid steers, bobcat kind of things, or reach stackers, which can place single containers to see if there's a benefit and if it's also feasible to operate them, and learn in our pilots how this could benefit the operation. And then the last part is platooning. Now that you heard the word platooning, you're probably thinking, platooning, that's like 5 years old. What is this of a bad idea? Well, I can assure you, we knew, but it's it's an interesting to think of because platooning in its classical form, you are still having a driver in the second vehicle, so you are paying a second driver to do nothing basically. So, although technically proven already for a few years in its basic model, there's a business thingy that does not work very well. There's also the other thing that you can drive closer and you can reduce fuel consumption, and that's then your business case. Could be interesting in Australia or the US, where you have these really long stretches with no exits or entries. But in Europe, especially the Benelux, there are so many entries. There's not really a lot of fuel potential to be gained. But if you add teleoperation to it, then you change it because if you then you can take the second driver away from that vehicle. You can drive teleoperated with two vehicles to the highway, and then when you are making a platoon, the second driver can swap out, and then there is a business case on personnel also. So that's an interesting thought. And that's what we are exploring, and we are then starting from your normal platooning, but really looking what does it mean to add teleoperation, what technology the changes that we need to do, and so on. So that's our fourth use case in the project. And then these enabling functions, like I explained, these are the first part. I think the first five are on safety. The enhanced awareness dashboard, the number one, it's a generic function that basically brings all possible warnings about there's an incident in front of you, there's a traffic light approaching on red, whatever. It's the funnel that brings it all to the operator. That's enabling function one. Enabling function two is interesting, and it's also valid for automated vehicles. If there's no physical driver in the vehicle anymore, it's harder to interact with a pedestrian or a cyclist. Normally, you can just give them hand signs to make them aware of what they need to do. We are missing that, and we are also a bit missing the good visibility on them. So we are working on an app-based solution, a prototype that indeed the cyclists are known by the driver because they share their location, and the other way around, you can give them feedback on "I have seen you," and this way we are exploring if you could indeed safely interact without being physically present with vulnerable road users in your environment. The third one is related to those platoons I just mentioned. If you are already platooning before you're on the highway, for instance, you start on a factory with two trucks that already form a platoon when they start, and you are going towards the highway, then you would have only one teleoperator in the front, no one anymore in the back, and digitally coupling them into a platoon. You don't want to break up that platoon at the traffic light because then suddenly you are stranded with the vehicle, the second one, with no driver. Then you need to urgently swap someone in. The capability for being able to urgently swap someone in is quite expensive because then you have to overdimension your operators. It would be better if the traffic light just knows this is a platoon coming through. We can't break it up. Give it a reservation and then make sure it goes through in one piece. So that's that enabling function. Enabling function 4, distributed perception, is again in that thought of you want to increase the situational awareness digitally. So we are investigating if sensor measurements from other vehicles, LiDAR and so on, measurements from other vehicles, the results of that object recognition, if you could share that with each other to have even a better situational awareness. So that's enabling function 4. And enabling function 5 is an additional safety measure on the vehicle itself, because as mentioned, we are trying to really target public roads driving, not only confined port areas and so on. 5G promises to never break down the connection, but what we have learned is you can never hardly, and you can't guarantee that 100% for sure. If power breaks down or whatever, it's you can give a lot better guarantees than in 4G, but it's still a network. Things can always break. So if when you get disconnected or your operator station breaks, that's also possible. The vehicle has to come to a safe stop. So those are the built-in functions we are adding on top of the standard teleoperation to come to a safe stop. These are the first five on safety, and then the last three are on optimizations of the logistic chain. The first one, container ID recognition. Teleoperated vehicle has cameras all over the place. It's looking in front for the teleoperator by definition. It's interesting to see if you take these video streams and put them to some AI functions, then they could learn which are the containers we are grabbing because they always have IDs, and then you could, without putting any additional RFID tags or whatever, have a continuous awareness of your logistics system on where are these containers being placed and what they are doing and so on. So that's an interesting part in terms of making use of capabilities originally for teleoperation to further enhance the business case. ETA sharing is the same. If your teleoperated vehicle is so connected, then you could indeed, the track and trace system, have it share when it's arriving with planning systems at the harbor. And then you could further optimize, for instance, when things have to be put at buffer parkings or be taken away and so on. And then the last one, scene analytics. That's also a special one. A teleoperated truck, for instance, when it's parked, has no driver anymore. So if someone breaks in, you don't know, as an example. So with scene analytics, you could use sensors, for instance, at that parking. They don't have to be cameras. They can be, but they can also be sound sensors, for instance, if you are concerned about privacy, so that you could have anomaly detection on these input streams to really identify there are chances that something's wrong with that truck. Maybe before it leaves, someone physically present has to double check it and so on. So these are all the different elements on top of teleoperation that we are exploring in the project. And we will be piloting them in three different areas. So it's the project itself is really focused on Flanders and the Netherlands. I think the majority of our consortium, we are 26 partners, and 24 of them are Flemish or Dutch. And so our pilot sites are also in that same area. So what you see here is we have Vlissingen, Flushing, is one of our three areas, and then the other one, Antwerp, is in Flanders. These are national sites. There are no cross borders there. But the third one, Zelzate Sas van Rent, that's an interesting one because there you have a border crossing which combines the waterways and the normal roads for the trucks. So there we can try seamless handover, really driving over the border and not losing connectivity as you proceed, both on the waterways and the roads. Especially for these waterways, it's interesting because we see that the solutions developed to be brought to real deployment, they are more and more adding automation already to it. So they are not always sailed manually unless there are reasons to do so. For instance, a busy port because the traffic there is too dynamic, or if they are kunstwerken, they call it in Dutch, yeah, obstacles like a bridge in the water. Then they have to sail manually from remote location. And especially at this border, there's a bridge, a big bridge, Zelzate Bridge, just beyond the border. So that's a trajectory they just can't do today because they will lose connectivity just before that bridge. They black out for 30 seconds with the current network. So that's something that we really hope to solve for them and really enable them to go also on these trajectories. I won't go into much detail because I think it's a relatively boring slide if it's not a project partner to which it is presented, but the people from Blueprint, I think, know this by heart. It just defines for the different pilot sites which use cases we will do and which enabling functions we will combine with that use case, because not every combination makes a lot of sense. So yeah, I think it makes clear that we have an ambitious set of plans, basically. And then here I have some pictures on the actual sites. So so this is Flushing, Vlissingen Oost, where we have two partner companies, Verbrugge and Kloosterbosch, at those docks that you see depicted. And this is the actual factory where we will try the automated docking. so where you really have these small margins. That's the site where we'll do that. And then in the same area, we will have two different trajectories to drive. The first one is here from the MSP factory to the quay at Kloosterboer. This is what we call a milk run. I have been informed that it's not exactly correct in logistics names, but it's so easy to understand that everybody keeps calling it a milk run. What we mean with that is milk runs, in our definition, are trajectories you do a lot, always the same, just a few kilometers in the same area, like from a factory where you load up the containers to the quay where they are put on a barge. And this is an actual example of that factory MSP Onions, where they told us before the project, when we visit that in another context, that they said, yeah, it's hard to find truck drivers who want to do this. Okay, they are not away from home, so from that perspective, it's a nice 9 to 5. But doing this small trajectory for the rest of your life, day in, day out, is also not the most appealing job offering. So that's why that's interesting to see. Yeah, these are just a few drives per day. Yeah, with the teleoperator service that combines a lot of these milk runs in a specific port area, that could be interesting in terms of customer potential. You have a relatively manageable area for deployment of your network, your services, and so on. We see a lot of potential value in these milk runs being teleoperated. They are also not yet on the highway, so slower speeds and so on. That's important because we do notice, and I'm sure this will be presented today also, the quicker you drive, the more important the extra low latency becomes, just because you're driving quicker, and it's more realistic to do these drives and already target 90 kilometers per hour at the highway. So that's very interesting. Then, yeah, the other trajectory is from the factory to the future buffer parking of the area, because we have two traffic lights that we will upgrade to intelligent ones in the project to have that platooning priority tested at these traffic lights. Then Zelzate, this is that cross-border area, so the border really goes over this canal where you also have the road next to. But it's also interesting because in the same area we have quite a lot of urban environment and so on. So it's in a few kilometers of trajectory we have a lot of different environmental conditions that we can play around with. So this is the full trajectory. So you'll see this is this bridge in Zaalzate. This is the border crossing. So we'll sail back and forth with these barges, and then with the vehicles we'll drive in these loops. And then you'll see that this is an urban area, with also, again, three different traffic lights that will be upgraded. This is more rural, again, more urban and more industrial. So just to learn, is the connectivity reliable in this kind of environment? How well is the visibility for a driver, and so on? This is a very, very interesting setting. And then the third part, the Antwerp site, that's near the premises of one of our partners, which is a transport company, Roosens. These are their offices. If you can't see that. This is their office, and they have, for instance, an interesting case that when they leave with the trucks, that this bicycle lane, they can't really see the cyclist well most of the time. So there we will try to see with these scene analytics, for instance, for burglary I just mentioned, if you could also add cyclist detection at dangerous spots to warn the teleoperator that the cyclist is coming to improve safety. And this is then the map overview. So this is the premises of this transport company. So we'll drive around, and then this here is the bicycle lane. And then once they leave, we will do again a milk run of a few kilometers to the quay. Because for a transport company, we've learned that this is also something they do quite often. That's container pickup and container drop-off, which are very similar, like the factory needs to bring its goods to a few kilometers further. A lot of transport companies basically are their own buffer parking. For the longer haul, they get plates at their side, and then they do these pickups and these drop-offs. Okay, so I'm just looking at the time. I think I have time. Okay. The business modeling then. So yeah, I've been focusing now a lot on the technology. The business modeling is also an important element, and we do it in a stepped approach. So we started with the business case analysis that's really focusing on the transport sector alone, just from the idea. If we would take away that driver physically from the vehicle and put him or her in an operator center, would we have enough financial gain to be able to pay for all the extra costs that come with this. So there's the HZ University already looked at that, and there was a positive business case. So that's a good starting point. There was, yeah, because we didn't know that upfront before we investigated in detail. So would be less enthusiastic if there wasn't, but there was a positive business case. And then we try to go deeper and deeper, of course. So the next step is then to define your value network, the first one, and then more and more complete it, make it broader, and try to identify first business models where your value network can act together in such a way where we expect everyone to have a positive business case, because everyone should have. We are companies at the end of the day. So that's something that's ongoing. Then we're also looking at really the cost benefit, the techno-economic analysis, to see, okay, how much does this all cost? What's the economic impact for the different actors? So that not only the business model and the way how they interact is known, but also exactly how much we expect them, ballpark figures, to be able to make. Because yeah, final figures you can't calculate. That's so dependent on every individual company, but at least some better understandings than what we have today, at least. And then of course we'll try to validate all these learnings also from what we learned technology-wise in the pilots. Yeah, if you learn that you need smaller cells than you thought first, yeah, that changes of course the cost and so on. So there's all the pilots, the technical tests, and the business modeling all have to come together. And in the end, for that blueprinting, we really want to have insight in the business model, what deployment scenario is feasible and what not, and also on governance, some recommendations. Okay, so this is everything we are doing. This was the scope. With whom are we doing that? 26 partners. I present them briefly just per category. So first of all, we have our network operators, Belgium and the Netherlands. So we have two big players, KPN at the Dutch side and Telenet at the Belgium side, and then Eurofiber as a specialist in fiber connectivity towards the needed base stations and so on. So we have the different angles of network capabilities in our consortium. We have then a vehicle OEM, Toyota. So that's something I didn't mention yet. To be able to how to say, agile is maybe misusing the word, but to step up from easier to harder. We start with vehicles with cars first, not because cars are so easy, but they are a better first step than immediately on the big truck. So we are starting first with Toyota cars, which are then made teleoperatable. We have two of them in the project, and then we go to our big truck. So that's why Toyota is in. And then the people making these cars teleoperatable, these are our specialists. So RoboAuto and Vitron, these are really working on the teleoperation of the cars. CFAR is working on the teleoperation of the inland barges, so the ships. And then MWLC is adding additional capabilities for that evolutionary part towards automation later on. And then, because we focus so strongly on the logistics sector, we have quite a lot of players from the logistics sector. So really, from the transport sector, we have Kloosterboer, Verbrugge, and Transport Oceans. So these are the day-to-day operations, not technology, but is doing transport or other logistics services. Then we have two ports in the project, Port of Antwerp and North Sea Port, in which we do the pilots also. And then we have some software specialists for logistic software solutions. Centors, they do this container ID recognition, Roomforce Zero, and Export also. And then I mentioned before, for these enabling functions on safety, we are evolving the CITS domain, or the connected mobility, how you want to call it. We have several specialists in the project for that, B-Mobile, Sparco, and Locatinet. And then, of course, it's a research project, so definitely also need the academic perspective. For that, we have IMEC, Han University, and HZ University. And then the last two parties you see here are business accelerators. They are really the oil in our machinery, bringing it together. That's Martel Innovate and Impulse Zeeland. And then finally, the governments are also involved to really have an exhaustive view on the challenges ahead. I myself, I am from the ministry, the Dutch Ministry of Infrastructure and Water Management. We are also coordinating this project. And our counterpart in Flanders, Mobiliteit en Openbare Wijken, is also involved. Okay, So those are the consortium members. Then we have an advisory board with some people devoting time to interact with us and to provide us feedback on how we are evolving. From the governments, the province of Zeeland, city of Antwerp, and Agentschap Telecom in the Netherlands. Then also interesting from the vehicle side, two different truck companies. So because indeed we are targeting the trucks, so we are in constant dialogue with them. So Ford Otosan from Turkey and DAF from the Netherlands. And then additional players from the logistics sector, Port of Amsterdam, Port of Rotterdam, Transport Logistics Netherlands, TLN, and then ICBO, which is a representative of inland container barging stakeholders. So I think I'm roughly at the end of my talk. Some typical figures, could have presented them in the beginning also, but so the Blueprint project is taking 3 years. We started a year and a half, a bit more than a year and a half ago. Some people from the project I've met today for the very first time, so go figure what a strange environment it is to work in. But I'm really glad that for our second, the most exciting part of our project, doing the testing, we can just come together. So that's very, very nice. We have a 10 million euro contribution from the European Commission because it's a Horizon 2020 project. I'm the coordinator, and the technical coordinator is Johan Marquez Baja from IMEC. So that concludes my talk. I hope you found it interesting. Just the key highlights for me is that we are working on that teleoperation use case, which is in all honesty quite challenging for the network. I haven't mentioned that yet, but I think we have to be aware it's combining the high capacity, the high bandwidth of eMBB with the critical features of URLLC, and all of that in the uplink where you typically are less dimensioned than in the downlink. So it's stretching 5G to its limits. In the theoretical approach, at least. That's what I've learned from all the preparations. We still have to do our first pilots this summer, and then the second wave next summer. So in next talks, I really hope to be able to give you more results than just overviews. But that's something I personally already find very interesting. From all the use cases we could investigate, I think this is the one that really brings 5G most to its knees, so to say. But that's a nice research challenge, so that's always good. We are looking not only at technology but also at business and governance questions. We are focusing on the transport domain. We aim to have a roadmap at the end, the blueprint, to be able to really deploy this after this project, or at least know how to continue towards that. And like I just said, please stay tuned. We'll have actual results next time you see us. We are starting the pilots in June, so I hope to be back for all of you and give you some nice learnings then. So thank you for your attention. If there are any questions, please go ahead.
Thank you, Wim. Any questions for Wim?
Yeah, Wim, thank you very much. Thank you very much for your talk. You mentioned that the business case is a positive one. Could you elaborate on what the challenges are in the business models? What do you see there, and do you have a clear view on the end state?
Yeah. Well, the business case, the first step, still had a lot of assumptions, right? So if you want to calculate that logistics-based business case, you want to see how much can I gain. So we had a model on how many operators to vehicle ratio you need to have, how much money you save. Then you have to put that next to how much it would cost. And these are still a lot of assumptions. So in the current assumption set, there is a business case of a few percent of the turnover. Personally, I found that not that attractive, but then talking to the logistics the experts, it's a really low margin sector, and a few percentages of profit is already a big difference. So that's why I said, okay, there is definitely that potential, but it's still based on a lot of assumptions that were not known at that moment. So now in the business modeling, when you are getting more into detail on how can you act together, you can really learn. Okay, these assumptions have to be retweaked like that. This changes the business case. The personal feeling I'm having now is, for instance, long haul will be harder than we thought because for the long haul, with real direct control teleoperation, you need a lot of 5G network along your highway, and even if you put all that expensive infrastructure there, as soon as you have 10, 20 trucks in a cell, you still overload that expensive cell. So you have to find a better balance between where do you do the actual teleoperation, for instance, in the harbor environment, and where do you already have to add automation before you go to deployment. And the highway, for instance, that's an operational design domain where automation is not that science fiction, I think. So that's something we are thinking of in the business model, how to balance teleoperation and automation in one complete package. Yeah. But those are all thoughts, lot to learn still. Yeah. Yeah. Yeah.
Any more questions?
Just looking a little bit forwards. Do you expect that we get kind of driver centers, same as call centers, where you can set up a lot of drivers on the row and let them drive, pick up your truck and bring it there?
I think we will. The question is how big will the area be that they will cover? But what we learned from that first business case is that if the more you scale up that service, the more cost efficient it becomes. So it's better to have one center, for instance, for the entire port, than have every small transport company in the port have its own tree setups and its own office. So I do expect that to consolidate a bit. The question is, will it be, for instance, on a port level, on a regional level, on a national level, or even international? That's something we still have to learn because we also don't know yet how closely the operator station needs to be tied to the network of the vehicle. So if you put the normal internet in between, you have less control on these keep on these characteristics of the connectivity. But maybe that's okay because the normal internet maybe is good enough. So we still have to learn all that. Yeah, you could even think of having people from the other side of the world drive by night here, but then you have cross-continental connection. I think we are not really exploring that. I think now we are just looking at could we have one for the Benelux, or do we need one per country or one per province, basically, or per port? But yeah, these are all things that come to mind when investigating this.
So another question. Yeah.
Did you look for a business case at first mile, last mile transportation?
How do you mean?
Shuttle systems. So they did, like in Capella aan de IJssel, for instance, that kind of systems. Because I thought these systems are fully automated, but these vehicles break down sooner or later. They will, and nobody can solve that because they only have passengers.
Yeah.
And the operators are already there. If you can make those teleoperated, that would be beautiful. Because if one breaks down, the whole system stops.
Yeah. That's a point. We are focusing on logistics, but we try, especially also from our ministry, it's interesting to learn where could we try to adopt this later on. And this is one of the ideas we are exploring. That's the typical approach to teleoperation. Before we did the project, that was always how you presented, that you have a fully autonomous vehicle, and when it breaks down, you take it over remotely. So that's still a valid case, right? That's still a valid case. Also 5G Croco, 5G Mobix, these are showing that. We wanted to challenge that a bit. In all honesty, when thinking of the project, personally, I was really at the bottom part of the draft of disillusionment of automated driving. It was 2018, 19. Okay, the hype, this will never happen. Let's do something differently. Now I have to come back from that and learn that as we mature, that we learn that things are not black and white, and that you should combine them cleverly. So what you propose is still valid, but you could also think of if there are, for instance, trajectories that you can't do fully automated, but maybe have some equipment standby for peak loads, then you put an operator in it, because that's something we also learned. It's very interesting to have operators be able to drive multiple things. During peak hours, they can do shuttles. During non-peak hours, they can move containers in these milk runs. So those are also possibilities to further increase your business case. Yeah. Welcome.
Yeah, maybe it's a little bit related to the previous question, but I was wondering if you take into account unhappy flows, like the car breaks down or when an obstacle is detected. Will there be a local driver and running to the or bicycling to the truck? Or I think there are quite a lot of unhappy flows.
True, and that's one of the challenges also indeed next to the network technical work on extending the range of your trajectory. So long hauling, the idea I personally had at the beginning, okay, everyone 9 to 5 job and we can take away all people from home. That's relatively hard also for these kinds of things, because then you have to make sure that you have local services that can help you out if things go wrong. not said that this can't be organized, like the Wegewacht, I don't know the English word, but yeah, there are examples of how you could solve this. But then it really has to be a very infrequent thing that you have things going on with the unhappy flow. And that's something we still have to learn. Can we expect this to be sufficiently infrequent? Can you solve this with partner services and so on? Can you also do technology-wise things? There was at a certain moment a discussion, if we add a drone to the truck, it can at least inspect the vehicle and give you more information on what's going on. But maybe that's too technology-driven, and maybe it's better to have a good service of local people helping you out. So yeah, but those are also things to consider. Very good question. Yeah.
You were first.
In railway operations, they have something like ATO, automatic train operations. Is your project related to that? Because driving a train seems easier than driving a truck with rails and stuff, and therefore they can learn a lot from you, I think.
Well, in all honesty, the call for project also allowed us to do rail, but in the time constraints we had, we didn't have the time to make a consortium also including the rail. We started from our own network and so on. So that was a very practical reason. While rail is not in here, but business case and technology wise, as we are learning what the challenges are, this becomes a very interesting spin-off possibility because indeed, OTA is around for, I've only learned that recently, but around for quite some time. If you have level 2, to explain OTA level 2 is a train that drives itself, but you are still having your train operator looking out the windshield. And this is already running for 30 years in Czechia, I was informed. So it's technology that just works because again, of course, the operational design domain from a robot perspective is a lot easier for a train than for a car, right? So that works. The next step in that evolution in the rail world is that you still have that person on board, but not looking through the windshield anymore. No one has reached that level, but I think that's normal because what's the business case? It's like with the platooning, you're still paying someone to just walk around and bring drinks or whatever. So that's not the biggest gain you could have. It's the next level, the final level 4. That's interesting. There, where you say the train drives itself, and indeed, if it breaks down, then you take it over remotely. And I do think with our learnings here, that this is also very spin-offable to that domain. And we are discussing in the ministry with some colleagues on shouldn't we start doing follow-up work on that? Because yeah, the challenge is the operational design domain of automation is easier. The network deployment, fiber optics can be through Reliant as an organization that they can be procured already trackside. You don't have as many trains per hour, so per cell as with the truck. So a lot of these challenges for the long haul of what we see are solved by itself in the rail world. So I think it's very interesting to explore that further. Yeah.
By the way, it's not correct what you say about that there's not GOA4. In trains, there is. For metros, it's already there
True.
since the 1970s. And also, there are also some trains running GOA4 in several countries without a driver.
Okay, then I stand corrected. I was aware of the metros indeed, but I was thinking of norm, and I do know also in Australia, for instance, they are these railways. But that's for the mining industry. That's a very different situation than the normal train context that we would be looking for in Belgium.
But also many local trains that are already on the point of, or near to the point, for GOA for complete automation. For example, in Moscow, but also in some German cities, etc.
Okay, then I think we definitely need to talk after because, like I just said, this is a new learning for me. First discussion, so I'm not that aware of the state of the art. But to my understanding, at least, level 2 was already quite off-the-shelf technology, but level 4 is definitely not a commodity yet. Yeah.
Czechoslovakia is very basic.
Yeah. Okay, so, but I do hope that you agree with the fact that the learnings here, they are beneficial there. Voilà. So,
that's why I'm here.
Yeah, great. Thank you.
Final question.
Maybe one question. With the connected automated mobility, we are constant dialogue with the RDW about allowing vehicles and functionality on the road. I was wondering how they are looking towards trucks, driverless trucks with high speed on the road.
At the moment, we are mainly discussing the practicalities of just getting the permits to test on the road, the proof exemptions and so on. Because we identified for our learning It does not matter if there is a safety driver or not for just the technical learning and so on. So we will have safety drivers on board. So we are getting booth exemptions and we are talking to the RDW about that. We still have to follow up on indeed more the next to the practical thing, just the concept-wise discussions on what would it mean for our blueprint, for the governance and so on, to have them allow that on the road. That's work that should have started next month, but yeah, in all honesty, it's still on the to-do list. Yeah, but it's in scope at least, and that's important, I think.
Thank you very much, Wim.
Thank you.
Round of applause.